Good day, grade 12 learners. Welcome to our mathematics lesson. I am Sikhulile Ncube. This lesson is proudly brought to you by the Gauteng Department of Education in collaboration with Saipono Discovery Center and being broadcast by Pagama Research and Development. Right, today, grade 12s, we're going to look at the cyclic quadrilaterals, theorems, and their converses. Okay, so that's what we're going to look at today. Okay, in the previous lesson, grade 12s, we did what? We did the center theorem. So today we're going to look at the theorems that involves what? The cyclic quadrilaterals. Okay, right. Now I really hope that you are sitting there with all your resources. You have your books, you have your pens, you have your calculators and everything, and you are ready to learn. Because we are going to learn a lot of things today, interesting questions. You are going to enjoy this lesson. Let's be ready for the lesson. We're going to be starting very soon. Okay, let's start. Now, what are you going to learn at the end of the lesson? You are going to what? You are going to prove examinable cyclic quadrilaterals theorems. I have a problem with pronouncing this name. It's giving me problems. Right, okay, but I'll try. Right, prove examinable cyclic quadrilaterals theorems. That's what we're going to do. If I'll tell you that this one is examinable, it means that proof you must know it. Okay? Just like we did with the center theorems. Okay? You must know which ones are examinable. There will be a proof question in the exam. You must know that. So that must be 3 marks. Apply convex theorems and corollaries in typical examination questions. We're going to look at some corollaries. Okay? Right, these are deductions we get from a theorem. Okay, right now, refer to the examination guidelines. We're being guided by examination guidelines. So everything we're learning here is very, very important. It's according to the examination guidelines. Okay, theorems that we're going to look at today. I just want to give you a highlight of them, and then later on we're going to look at each and every theorem. Right, the one which says that an arc or a chord, remember these features in the circle? An arc or a chord of a circle subtends equal angles at the circumference of the circle. Okay? An arc or chord of a circle subtends equal angles at the circumference of the circle. Okay, please don't forget that. Okay, right. And then angles in the same segment are equal. So we call these angles in the same segment. Okay, when the angles are subtended by the same chord or the same arc, we say they are angles in the same segment. That's what we use for the reason anyway. We say angles in the same segment. Okay, I'm going to give you a picture where you're going to see all this. Okay, right. The other one you're going to talk about is opposite angles of a cyclic quadrilateral are supplementary. What do you mean by supplementary? It means they add up to 180 degrees. Okay. I hope we are not writing everything grade 12 so that we don't lose time. Okay, otherwise we write this thing, we're going to get tired of writing things. There are a lot of notes here, so concentrate on the activities. Okay, I'm going to be doing activities with you. Right, opposite angles of a cyclic quadrilateral are supplementary, means they add up to 180 degrees. Okay, and then we're going to look at the exterior angle of a cyclic quad. Right, an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Okay, are you going to remember these three? Please don't forget them. Okay, we said angles subtended by the same chord or an arc are what? Are equal. Subtended the circumference are equal. We say angles in the same segment. Right, opposite angles of a cyclic quad are supplementary. It means they add up to 180 degrees. We're going to prove this one because it's examinable. And then an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. We're going to apply this one. Okay? Right. We said an arc or a chord of a circle subtends equal angles at the circumference. Right. Do you see any arc that subtends 2 angles at the circumference here? You can shout the answers or any chord that you can create there that will subtend angles at the circumference. Can you see the arc? Right, do you see this one? I've highlighted it there. Arc CD or chord CD. Do you see that? So there's an angle here. You see? There's an angle here subtended at the circumference. Okay. And then let me draw another one. There's another one. This one. You see that? Is also subtended at the circumference by the same chord or the same arc. You see that? Now, these two angles, A and B, are equal. That's what we talked about in the previous slide. Okay? Do you see any other arc or chord that you can create? Okay, please, you can say the answers there in the classroom. Any other arc or chord that you can create to subtend equal angles at what? At the circumference? I see another one, another pair, an arc and a chord. I can see it. Do you see arc AB? Do you see that one? AB. Right. It's another one. Do you see that? It's another one. So there's an arc AB there, and we can have chord AB. Which angles are subtended by that arc AB? It's angle what? Let me try to pick another color. Right. You see that? Let's say this one here. You see? Okay, that's an angle there. C and D, they are subtended by the same chord. Right, and then there's what? There's another one. This one. Angle D. You see that? Subtended by the same chord. The angles subtended by the same chord of a circle at the circumference are equal. Don't forget that. We're going to apply that very soon. I'm going to be giving you what? Activities to do. Okay? Is that understood? Please try to follow what I'm trying to explain here. Okay? So now let's move on. Opposite angles of a cyclic quad are supplementary. We're going to prove this theorem. We're going to prove this one. When I'm talking about opposite angles, which angles am I talking about? Right. Okay? We're saying angle A. Let me see if I have. Okay, no, I didn't. Let me go back. Right. This is angle A. Right. Angle A here. And angle C here. These are opposite angles of a cyclic quad. Okay? And then we have angle B here and angle D here. They are opposite angles of a cyclic quad. So these two opposite angles, when you add them, they give you 180 degrees. Okay? Right. We say they are supplementary. Right. A, B, C, D. You see A, B, C, D is a cyclic quadrilateral because A, B, C, and D are concyclic. What do you mean by saying concyclic? It means these 4 points are sitting on the circumference. Okay, A, B, C, D are sitting on the circumference. They're concyclic. So A, B, C, D is what? Is a cyclic quad. Can I use cyclic quad? Just when I'm saying cyclic quad, I mean cyclic quadrilateral. Okay, right. And then the vertices of a cyclic quadrilateral lie on the circumference of a circle. Concyclic, I've explained this part. All the 4 points lie on the circumference of the circle. All points are the same distance from the center of the circle. That's what concyclic means. Right. And then we talked about another one. This one, we just need to know how to apply the theorem. We're not going to prove this one. You must know how to apply it. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Okay, we see that. So the reason we write here, we say exterior angle of a cyclic quad. Exterior angle of a cyclic quad. You can write that reason very fast. Exterior angle of a cyclic quad. You don't need to write the whole sentence, okay? So here we're saying that A1, which is this angle here, is going to be equal to which angle? Let's try that. Try to answer that in the classroom, please. You can shout your answers or raise your hand. You can even raise your hand and then say or ma'am will ask you to say your answer there. Okay, angle A1 is equal to which angle? Is equal to BDC. Is opposite, equal to the interior opposite. So it should be equal to angle C. Okay, so A1 is equal to angle C there. Okay, right. Anyway, I'd given you the answer there. Some of you could have seen that. Right, now that's the exterior angle of what? Of a cyclic quad. Okay, right. I've been talking for a long time now. I'm going to give you an activity too. But let me tell you something. When given a question, especially in Euclidean geometry, you are going to be given a diagram to work on. It's very, very important to use your writers and get used to filling the writers with as much information as possible. Okay, so now we are given a question like this. O is the center of the circle. I'm highlighting that. Why is it important for me to know that O is the center of the circle? I'm asking myself that question already. It means somehow there should be something to do with center theorems. You see that? Passing through A, B, C, and D, and then AOD is equal to 120 degrees. You see that? It's given, so there's no need to write that. BDC is equal to 22 degrees. DBC is equal to 68 degrees. Now, determine with reason the size of these angles, 1, 2, 3, 4. I want you to look at the information. I'm going to give you 1 minute to look at the information. And you fill in this diagram with as much information as possible. Okay? And then after that, I want us to look at this now. Don't look at this. Just look at the diagram and the information you are given, and you fill in the information. Before we look at the questions, let's do that. I'm going to give you 1 minute. Let's try. Welcome back, grade 12s. I really hope you managed to fill in some of the information there. Okay, let's do it together, and then after that we go back to our questions. Right, this diagram must be dated like we gave to write as many things as possible. O is the center of the circle, so it means BD. Do you see the line BD? It passes through the center. So what type of a chord is this? This is diameter. Remember, diameter is the chord that passes through the center. It is a special chord. Right, and then angle in the semicircle is equal to what? An angle subtended by the diameter is equal to what? It is equal to 90 degrees. So it means this is 90 degrees. We're filling the information here. This angle also is subtended by the diameter is also 90 degrees. You see that? Okay, this is 90 degrees. I don't need to write that. Once you see the symbol there, you know it means 90 degrees. Right, now look at this part. Okay, look at this. Right, this angle is subtended by what at the center of the circle? This one, this angle here, is subtended by what? By which chord at the center of the circle? Chord AD. Do you see that? This chord AD. Does this chord subtend an angle at the circumference? Yes. You see that? It subtends an angle at the circumference. Do you see that? Right. What do we have here? What do you know? An angle at the subtended by a chord at the center is 2 times the angle subtended by the same chord at the circumference. So it means this 120 is 2 times x. So what is x? It means x is going to be 60 degrees. You see that? I'm filling the information. Right, now, what do I have here? This is a radius. This is radius. So radii are equal. So it means this angle is also y because angles opposite equal sides. Do you see that? Okay. This is a straight line. Let me use another color. Okay. I hope you see what I'm trying to draw here. This is a straight line. This one is a straight line. You see, it's forming a y. You see? So it means we have adjacent angles on a straight line. Okay. So it means this one is going to be 180 minus 20. 120 is what? 60 degrees. Okay. So it means this one also is going to be 60 degrees here. This is an equilateral triangle. 60 degrees, 60 degrees, 60 degrees. Right now. And then what else? This side I'm covered. Right now, I can even find what the value of y is because these angles, y plus 120 must give us 180. So I must say y plus 120 is equals to 180 degrees. Right, means 2y plus 120 is equals to 180 degrees. And then 2y is equals to 60 degrees. Then means y is equals to 30 degrees. Some people just do this and say 180 minus 120 divided by 2, and then you write the reason. Do you see that? And write your reason. Remember, you always write the statement and the reason. Okay? There must be a reason here. There must be a reason. Angle is sum in a triangle. Okay? Every time. Don't forget that. Now, you see now, that's what you must do before you do anything. Okay? Right. Now, I'm going to give you 2 minutes to answer the question. Now, we've discussed everything, so now you must have an idea. Can you answer the question now? Find the size of BAD, BCD, X, and Y. I've given you an idea. Let's take 2 minutes trying to do that. Welcome back, grade 12. Did you manage to get your answers? It should be easy by now, okay? What do you get for the angle BAD? Which angle is BAD? This is the angle here. We're looking for the size of this angle here. And then angle BCD, did you get the size of this angle? Okay. What about X? Did you get the size of this angle? What about Y? Did you get the angle? This one. Ne? Okay, let's do it together now. So now, BAD, we're saying BAD is 90 degrees because it's angle in the semicircle. Angle subtended by the diameter. Okay, BD is diameter. BD, let me get the red pen. What happened to my pens? Let me see if I can get, okay. right? Now BD is the diameter. So angle subtended by diameter is what? Is 90 degrees. It's a right angle. Okay. What about angle? Every time you're getting the answer, sorry, grade 12, let me emphasize this. Every time you're getting your answer, fill in the diagram. Because the answer you're going to get, will use it in the next question. Right now, and then angle BCD, again, is going to be 90 degrees because it is subtended by the diameter angle in semicircle. So this one is also 90 degrees. Do you see that? Now we have the 90 degrees. We're filling in the information now, the correct one. Okay, as we calculate. Now the next one, we're supposed to find x. What is x? I'm saying x is 60 degrees. Do you agree with me? What's the reason? Because angle at the center, angle subtended by an arc or a chord at the center is 2 times the angle subtended by the same chord or arc at the circumference. So it means 120 is 2 times x. Okay, so what is x? It means it's 60 degrees. Okay, right. Please don't forget that we did this when you're doing what? The center theorems. Okay, so now we put our 60 there. Every time you get the angle, write the information on the diagram. Okay, right. And then now we have y. Y, I'm going to say this also is y, because it may be what? Because this is a radius, this is a radius. So radii, opposite angles, opposite equal size are equal. So now that's why this one is also y. Now we can say 120 plus y, it may give us what? It may give us our y value there. They must add up to 180. Okay, right. And then angle sum in a triangle. Then we get that our y is 30 degrees. So y is 30 degrees. We put 30 degrees there. You see that? So the way we are calculating things, it may be different. You may find that you're getting your answer, but using a different route. But please make sure that you write your statement and write your reason. Okay? Understand that? And then now, I want us to see something. Remember, it's not about the center theorems this week, but I want you to observe something. From this activity, we're doing two things. It's 2 in 1. Why? We revised what we did in the previous lesson. I'm also introducing today's lesson. You see that? Now we found that BAD is 90 degrees, and then BCD is 90 degrees. Look at ABCD. What can you say about those points? They are concyclic, meaning that ABCD is a cyclic quadrilateral. Okay? Now we need to understand this special property about a cyclic quadrilateral, where it's like proving it somehow. Okay, so we say this one is 90, this one is 90, and then if we add them, what we get? We get 180 degrees. Do you believe me now? Remember when I said that opposite angles of a cyclic quad are supplementary? Okay, do you see that this angle plus this angle is equals to 180 degrees? But this is not the way we prove it. I'm going to show you how you prove it. Please don't take this one as a proof. Okay, I'm going to show you how we prove this. Right, and then now let's add these ones. See if we're going to get 180. Let's add those ones. So we're saying here, if you add them, 30 plus 22 plus 60 plus 68, you will get 180. So opposite interior angles of a cyclic quad are supplementary. Grade 12s, you're not going to forget this. Okay? Right, we're going to prove this theorem. I will show you. Remember, when you're proving, we do our construction, and then we use other theorems to prove the other theorems. Okay? Right, now, I want us to talk about this. And then after this, we'll discuss the corollaries after that. Right, angles subtended by a chord or arc of the circle on the same side of the chord are equal. Okay? Know how to apply this theorem. There's no proof for this one. No, just know how to apply it in the examinations. Okay? So it means which angles are equal here? We have the arc here, which is AB. You can even draw the chord. Okay? The chord AB. You see that? Which angles are subtended by this arc and this chord? It's angle D and angle C. These two angles are equal. They are subtended by the same chord or same arc. Okay? Right. Please don't forget that. There's no proof for this one. We just have to know how to apply it. Okay. Right. Reason, we just say angles in the same segment. Remember in the introduction, we talked about this. That's the reason. Angles in the same segment. Are they in the same segment? Remember, we talked about segment when we talk about the features of what? Of a circle. Right. This is the segment. The minor one. Then the major one. Another segment. You see that? This is the segment. So now they are in the same segment. The chord divides the segment. Okay? To a major segment and minor segment. You see that? Okay. So now there are angles in the same segment. Okay? Right. And then from that, we can come up with our converse. Converse is that the other way around. So now if two angles are subtended by the same line, why am I not saying same chord here? This is not a chord because just a line. There's no circle there. You see that? Okay. If two equal angles are subtended by the same line, then the 4 points are concyclic. They're lying on the circumference. Then means now, then we can talk about AB being the chord after that. After we prove that ABCD is a cyclic chord. So we're saying that when the two equal angles, like this theta and this theta, are subtended by the same line, AB, then the 4 points, A, B, C, D, are concyclic. Don't forget that. Okay? Right. Now, let's move on. So, A, B, C, D lie on the circumference, meaning they are concyclic. Right. Again, I'm going to give you an activity using what we've just discussed. Okay? Using what we've just discussed. A, B, C, D are points on a circle. Okay? A is 35 degrees. C is 25 degrees. I don't want you to look at this now. I want you to look at the information and the diagram and fill in the angles as much as possible. I don't see a center there. So no one is going to talk about center theorems here. Do you see any center there? We have these lines meeting here, but they are not meeting at the center. I don't see a diameter there. We're not told about diameter. So there's no center theorem. You see that? So just look at the information in the diagram. Then everything will be fine. You know what? Here I'm talking about what? I'm talking about cyclic chord theorems. Center theorem is there. Just from the information. Okay? I want you to fill as much information as possible on the diagram. Let's try that. 1 minute. Right, very good. Right, if there's someone who understands there in the classroom, right, want to explain, want people to see that, please feel free. I want you to be able to even stand up and go to the screen and show others what I'm talking about. Okay? Right, now, someone can stand up and go to the screen and just follow this so that everyone can see what we are talking about. One person can do that, please. Right, now, we're at point A and D here. This is an arc AD. You start from there, you go till you meet at C, your fingers meet at C, and then start from AD again, you go till you meet at B. So we have this. Let me even draw a chord, but there's no need, it's an arc, it's fine. So we have this angle here. You see that? From AD. And then again, we have this from AD. So we have angles in the same segment. Do you see that? So it means what? X is equal to what? X is equal to 25 degrees. I don't know if that part of the questions they are going to ask me about x. No, not now. I'm not interested in that part. I'm just interested in the information. Okay, right. And then again, do you see another arc? Who sees another arc? Check this side. On the right. Is it on the right? Right, let's see this side. There is a chord there. There's this arc here. Arc BC. Okay, try to follow the angles which are subtended by that arc at the circumference. Right, let me choose a one. Right, this one. Do you see that? Let's follow that. Going there. You see that? From BC going there till you meet at A. Then from BC again, you move till you meet at D there. You see that? So this angle Y is equal to this angle, okay? Because they're angles in the same segment. Okay, same segment. They are subtended by the same chord. They are subtended by the same arc. Okay? Right. We'll see those who forget very fast because we're going to the question now. Let's answer this. First, I'm going to give you 1 minute because there's less calculation here. 1 minute, and then we look at the answers. Let's try. Right, welcome back, grade 12s. I know someone forgot to write reasons there. Did someone forget to write the reasons? It happens a lot to me. I forget, but that's not allowed. That's not Euclidean geometry. Every time you're doing something, why? When you're saying x is equal to 25, why is x equal to 25? You cannot just say x is equal to 25 from nowhere. So we must write our reasons. Okay, let's answer that. So we're saying x is equal to 25. X is equal to C there, angle C. X is equal to 25. Why? Angles in the same segment. You see that? They are subtended by the chord AD, both of them. And then, what about Y? Where is Y? Oh, at 25. I'm showing you there where 25 is. Remember, we always write on the diagram. Y is equal to angle A. Do you see that? This angle, right, is equal to this angle. What happened to my pen? Oh, it's fine. Right, is equal to this angle. Do you see this? Okay, they are angles in the same segment. So Y is also equals to 35. Y is equal to 35, not also. Y is equal to 35. Angles in the same segment. You see, it's very easy to get marks in Euclidean geometry. Very, very easy. But you have to practice it every day. It's interesting. It's interesting. Just take it like a game, whereby you just have your writers, you play around with all these things. You are going to enjoy it, I'm telling you. And you are going to enjoy this. Okay? There are a lot of marks in this topic. Right. Now let's move on. That 5 there. Okay. Now from this theorem, we can deduce and say that equal chords subtend equal angles at the circumference of the circle. Please don't forget that. And the reason is very easy. Equal chords equal chords equal angles. Reason done. Okay. So equal chords subtend equal angles at the circumference of the circle. We just say equal chords equal angles. Then you're done. Okay. Right. And then please don't forget that. Equal chords equal angles. Okay. Right. We can't draw everything, can't write everything. Otherwise, we won't manage to finish a lot of things that we have to do here. So just the key things. You can even write the reason there. Equal chords, equal angles. You remember, okay, as we do our activities, okay? Right. And then we have equal chords subtend equal angles at the center. The previous one was what? The subtend equal chords at the circumference. Okay. Now this one, equal chords subtend what? Equal angles at the center. What do you think is the reason? Let's look at the statement there. Equal chords, equal angles. Do you see that? Still the same thing. But now the difference is that is equal chords, equal angles at the center. Okay? This angle is equal to this angle. Don't forget that. Equal chords, equal angles. And then equal chords in equal circles. Okay? Equal chords in equal circles subtend equal angles. So we have three conditions here. Equal chords, equal circles, equal angles. You see that? So equal chords in equal circles subtend equal angles at the circumference of the circles. Okay? What will be the reason there? Equal circles, equal chords, equal angles. That's the reason you have to write. Remember that. So if you are told that these are equal circles and you are given equal chords, then look for the angles subtended by those chords at the circumference. Then those angles will be equal. Okay? Remember that. And then equal chords in equal circles subtend equal angles at the center. Just the same thing as the previous one, but now the angles are subtended at the center. Equal circles, equal chords, subtend equal angles at the center. What will be the reason then? It will be equal circles, equal chords, equal angles, just like the angle subtended at the circumference. Okay? These are the corollaries. Please remember them. Now, using what we have just discussed, I want you to try this one. Okay? Should I give you information? No, I'm not going to do that now. I want you to do Right, welcome back, grade 12. Did you manage to get the value of x? Right, what do we have here? We're saying we have equal chords, BC and AB. What do these equal chords do? They subtend equal angles. They subtend equal angles. You see that? So it means x is equals to 20 degrees. Okay, x is equal to 20 degrees. Well done, well done. I know you got this one right. So equal chords subtend equal angles. Okay, right, let's move on to the next question. Or remember the reason, grade 12, equal chords, equal angles. Okay, now activity 2. You want to try? Right, let's do it like this. I'm going to give you 1 minute to try on your own to fill in the information. Don't answer the question. Just fill in the information like we do. And then after 1 minute, I'll come back. We'll fill in the information together. And then after that, we finally answer the question. Okay, let's try that. Just fill in the information on your own for 1 minute. Okay, let's try. Welcome back, grade 12s. A, B, C, D are points on the circle. Q is a point of intersection. It's not Q, sorry. It should be M here. Right, M is a point of intersection of AC and BD. This M here, this M here. It's a point of intersection. There's another information there that you need. Intersecting lines. Do you remember intersecting lines? And we're doing this thing in grade 8, grade 9. Do you remember that? Okay, when it comes to intersecting lines, what do you think? Vertically opposite angles, adjacent angles on a straight line. Do you remember those things? Okay, right. So because of that, remember those things. Don't forget them. And then what else? We're given that CD is equals to AB. You see that? So it means we have equal chords here. Meaning what? Meaning that this angle here subtended by AB is going to be equal to this angle here subtended by DC. Okay? So it means this angle also is X. And then what do you see here? I see a triangle. I see a triangle there. Okay, let me use another color. Okay, so that you can see. You can see a triangle there. You see that? And then angles in a triangle, they add up to 180 degrees. And then we can find our X. Okay, now I want you to try this on your own now. Can you find the value of X now? Let's try. 1 minute. Welcome back, grade 12s. Did you manage to get the value of X? I really hope so. Right now, we're saying A2 is equal to D1, okay, is equal to X. Where is A2? This one. We gave you the reason for that. Equal chords, equal angles, okay? Now, then if you say 42 plus X, you must get what? 180 degrees because angle sum in a triangle, okay? And then we can solve for X from here, okay? This is 2X, so it becomes what? 2X equal to 180 minus 42, and then you get that, and then divide by 2 both sides, you get that X is equal to 69 degrees. Did you get that? Please mark your work, Then remember, statement and reason is very, very important. Okay, now, 2 equal circles are given. O is the center of circle FCD, and Q is the center of circle ABE. Determine the value of X. I'm not going to say anything. Read the information and answer the question. I'm going to give you 2 minutes. Let's try. Well done, grade 12. Did you manage? I really hope so. Let's discuss the question now. Two equal circles are given. And then we can see here that this line AB, the chord AB, is equals to chord DC. So it means here we have equal chords. We have equal angles, equal chords. Meaning that we have equal angles, equal circles, equal chords, equal angles. You see that? I'm suspecting that. Right, and then O is the center of the circle. Again, I'm thinking now, they're saying O is the center. They're talking about the center now. There must be center theorem here. You see that? Okay, right now. And then Q is the center of circle, APE, something like that. Now, let's fill in the information here. Now, we have the angle subtended by DC at the center being 110. So, the angle subtended by DC at the circumference is going to be what? It's going to be, what is half of 110? I think it's 55. Am I right? I think so. 55 degrees. You see that? Okay, 55 degrees. Right. And then here there's chord AB, there's chord DC. So these are equal chords in equal circles. So it means they subtend equal angles at the circumference. It means this angle here and this angle here are equal. Therefore, x is equal to 55 degrees. Done. Let me go and look at the question now. It says, oh, they said I must find x. I already did that. So let me just write my things nicely now. Okay, so it's going to be like this. We're saying angle F1 is equal to angle x. Okay, equal circles, equal chords, equal angles. Okay, so this angle is equal to this angle because equal circles, equal chords, equal angles. And then now it means that angle F2, angle F1, this one, okay, is equal to angle is equal to 55 degrees because angle at the center is 2 times the angle at the circumference. So therefore x is equal to 55 degrees. Getting all your marks. You see, please try to read the information. Don't rush to the questions, grade 12s. Read the information. Your answers are in the information. Your answers are in the information. Once you do that, then you're fine. Okay, right. Now, that is that there. Oh, yes, I'm just showing you the writing on the diagram. Okay, now, there's this theorem here. I said it's going to be, or it is examinable. It means proving this theorem, you may find it in the examinations. Please know how to prove this. Remember we said the baseline, we discovered that the opposite angles of what? Of a cyclic quad are supplementary. They add up to 180 degrees. We want to prove that now. This is how you prove it. Okay. Opposite angles of a cyclic quadrilateral are what? Are supplementary. They add up to 180 degrees. So we're saying here, before I go there, opposite angles of a cyclic quad. That's the reason. So we're saying angle A plus angle C is equal to 180 degrees because these are opposite angles of a cyclic quad. So this angle here plus this angle here must give us what? 180 degrees. And then this angle and this angle must give us also 180 degrees. The blue ones, these are interior angles which are opposite in a cyclic quad. And then D and B also, they are interior angles which are opposite what? In the cyclic quad. Do you see that? They are supplementary. Let's prove that. What do you do? What do you think we have to do here? How can we do our construction? Okay, given the cyclic quad ABCD, then we are saying that angle A plus angle C is equal to 180 degrees. We want to prove that. So you do a construction. Please remember, you won't get any marks if you don't do your constructions. Right now, you construct, okay, OB like that. And then you construct OD like that. Do you see that? Now, what do you see here? The center theorem. Can you see the center theorem? An angle subtended at the center is 2 times the angle subtended at the circumference. So now I have my 2 angles here, O1 and O2. O1 and O2. Do you see O2? What will be the size of O2? It is at the center, subtended by BD at the center. And BD is subtending A at the circumference. So what is angle O2 in terms of A? It is going to be what? It is going to be 2 times A. Do you see that? So angle O2 is going to be 2 times A. And then what about O1? It's subtended by BD at the center, but BD also is subtending C at the circumference. O1 is going to be 2 times C. Do you agree? Right, this is the angle at the center, subtended by BD. This is the angle at the circumference. Sorry, this one is the center now for what? How did I make this one? This one goes with this, okay? And then this one goes with this. Let me use the colors. So now, where are the things? Oh, let me go back. It's going to confuse. I thought my colors are going to come fast. Now, so this angle here is 2 times angle C. This angle here is 2 times angle A. Now, what type of angles are these ones? They are angles around a point. Do you see that? They are angles around a point. And the angles around the point add up to 360 degrees. So it means 2C, 2 times angle C, plus 2 times angle A must give us 360 degrees. You see that? And then you can have something like that. 2 times angle A, which is this angle, the blue one, and 2 times angle C, which is the red one, must give us 360 degrees because they are angles around a point. Do you still remember how we got to A? We said angle at the center is 2 times, okay, angle at the center, sorry, angle subtended by the chord at the center is 2 times the angle subtended by the same chord at the circumference. You remember that? So this one is going to be 2 times A. This one is going to be 2 times C. I want to go back there so that we understand. Otherwise, now adding these two to get 360, I think is easy. Now, so 2 times A plus 2 times C is equal to 360 degrees. Let's factor out 2. It's a common factor. It's the highest common factor. So we remain with something like this. And then we divide by 2 on both sides. We remain with A plus C is equal to 180 degrees. What is our A? This is our A. This is our C. And these two angles, if you add them, they give us 180 degrees. We have proved that the opposite interior angles of a cyclic quad are supplementary. They add up to 180 degrees. Don't forget that. So these two angles add up to 180 degrees. Okay. So similarly, grade 12s, we can do the proof to prove that angle B plus angle D is equals to what? Is equals to 180 degrees. Okay, we don't need to do the whole process, but let me just show you the construction if they asked you to do that. You just construct like this, okay, and then let me just show you. You just say this one is 2 times angle D, and then this one is 2 times angle B. You see that? Okay, and then 2 angle B plus 2 angle D is equals to 360 degrees. Okay, angle is around a point. Okay, you see that? Right, how I got this one, I said angle subtended by a chord at the center is 2 times the angle subtended by the same chord at the circumference. And then you factor out your 2, then B plus C is equal to 360 degrees, and then B plus C, angle B plus angle B is equal to 180 degrees. So we can prove in the same way. Okay, right. This is how we prove this theorem. Please don't forget that. Okay. Okay. I was saying the opposite angles. Should I erase this so that you can see? It looks clumsy now. Where is the eraser? You can erase this and see this thing nicely. Okay. You can see now the opposite angles of a cyclic quad are supplementary. Don't forget that. Opposite side of a cyclic quad are supplementary. Okay. Right. Let's move on. The converse. The other way around now. Okay. Now we say that the opposite side of a cyclic quad are supplementary. Then now, if the opposite side of what? Sorry, did I say opposite sides? Opposite angles. I'm getting tired now. Opposite angles, if the opposite angles of a cyclic quad, no, of a quadrilateral, I cannot say it's a cyclic quad, right? The opposite angles of a quadrilateral are supplementary, then that quadrilateral is cyclic. Do you see here I've got a quadrilateral, A, B, C, D. I didn't say it's cyclic, but now if it has angles like these ones, where you say 100 plus 80, then this is cyclic. Then you can conclude and say it's cyclic. That is the converse of that theorem, okay? Right, you can conclude and say it's cyclic like that, okay? Right. Now, okay, I think we've done this part. We've done this part, okay? Now, I'm going to give you an activity. And I want to give you 4 minutes, okay? 4 minutes to try to find the value of x, the value of y, and the value of z, okay? We're almost there. I have about 3 more activities that you can do, and then we'll be done. Now, try to find the value of x, y, and z. Very, very easy things, please. Let's try for 5 minutes. Well done, grade 12. Did you manage to get the answers? Let's try to discuss the information before we look at the questions. I hope there's no one who was tempted to say x is 90 degrees. Because AC is not diameter, we're not told that. Please cannot assume. So sometimes we may get such questions. People will be tempted to think that AC is what? Is diameter. No, it's not diameter. We're not told that. We're not told it's diameter. So A, B, C, D are points on the circle. Angle D is 70 degrees. ACD is 30 degrees. You can see that. And ACB is 42 degrees. Now, we can say if we add this angle and this angle, we must get 180 degrees because these are opposite angles of a cyclic quad. So it means x plus 70 degrees must give us what? 180 degrees. You can even do your calculations if you want. Okay? Now, this angle and this angle and this angle, they are angles in what? In a triangle. So angle sum in triangle there can work. Okay, we can find y. Even here, after getting the x here, we can find z. The other thing that we can have is that this angle here, the angle BAD and angle BCD, they are opposite interior angles of a cyclic quad. So it means they add up to 180 degrees. You can use all those things and then we're going to get our answer. Okay? Is that clear? Now let's go to the solution. Let's find x. So I'm saying that angle D and X must give us 180 degrees because these are opposite angles of a cyclic quad. Do you agree? Yes. So now we can find X because D there is 70. So we're saying 70 plus X is equal to 180. And then so therefore X is equal to 180 minus 70 degrees. And then X is equal to 110 degrees. Then you can write 110 degrees on the diagram there. Okay? Right. Now let's move on. The next one. Y. This angle plus this angle plus this angle, the angle is in a triangle, so we can add them and then get 180 degrees. The reason angle sum in triangle. Then we solve for y. You see that we can solve for y. Now we're saying y should be equals to 180 minus 70 minus 30. Y is equals to 8. Is it true? Oh, this is negative 100. Yeah, fine. I thought maybe the answer is 100. So that is y is equal to 80 degrees. If you subtract 70 and 30 from 180, you get 80 degrees. Okay? You see that? So if you look at the diagram and the information before look at the question, it will make your life very, very easy. And then Z, now we can even use angles in a triangle, but I want to show you because I'm emphasizing the opposite angles in of a cyclic quad. So this angle here plus this angle here must give us 180 degrees because these are opposite angles of a cyclic quad. So it means this, okay? Then you can say Z plus 80 plus 30 plus 42 must give us 180 degrees, and then we solve for Z. That is solving an equation, a linear equation. Should be very, very easy for you grade 12s, okay? Now Z is equal to 28 degrees. Done. Was that difficult? It wasn't, isn't it? It wasn't difficult. So I'm going to be giving you time to try things. Okay, first you try on your own. Even I'll give you 5 minutes to do things, and then after that we discuss, isn't it? Okay? Now we are applying what we have learned. We are applying what we have learned, okay? Right. Now that is that. I want you to try this one. Again, I'm going to give you 5 minutes. 5 minutes to try this one. Let's try. Right, well done, grade 12. Let's discuss the information. O is the center of the circle, with points A, B, C, and D in this on the circumference. I think the preposition there. Right, angle C is 40 degrees. We have it there. Determine the value of the angle X, Y, and Z. Right, let's discuss the information before we look at those questions. So now O is the center and BC is passing through the center. So it means BC is the diameter. And then Y is subtended by that diameter. So it means Y is 90. This is interesting because now we're going to be able to find Z because there are angles in a triangle. Do you see that? So we can find Z now. So it means Z is going to be 50 degrees. Okay. You can say even complementary angle is there, Z and 40 there. Okay, they must give us 90 if we add them. Or use angle sum in a triangle. Right, now, what else? If I see this angle here, what do you see? It's a cyclic quad, remember? So, this angle here, and this angle here. Okay, what do you think? Please don't think that the cyclic quad is always what? You can have a cyclic quad like this. Okay, this is a cyclic quad. As long as there are 4 points, A, B, C, D. People will always think that the cyclic quad must be something which is like this. No. As the 4 points are concyclic, it's a cyclic quad. Okay, so now this angle here is equal, not equal. They add up to 180 degrees. They are supplementary. If we add them, they give us 180 degrees. And then these ones also, these two, if we add them, they must give us what? 180 degrees. Do you see that? So what will be this angle X here? It's going to be 180 minus 40 is going to be 140 degrees. Okay, and then, okay, then you can find Y 90 there, Z there, and X there. You see that? Now let's go to the question. Right now, X, we're saying that X is going to be angle BAD and plus angle BCD. They must give us what? 180 degrees because they are opposite angles of a cyclic quad. So now we say X plus 40 is equals to what? 180 degrees, meaning that X is going to be 180 degrees minus 40 degrees, which is 140 degrees. Do you see that? Sorry, 180 degrees minus 40 degrees. Yes, I'm right. And then X is going to be 140 degrees. Do you see that? Okay, write your information on the diagram. And then let's find Y. What can you say about Y? Y is 90 degrees. Y, angle in the semicircle. Okay, angle subtended by diameter because BC is diameter. So this one is 90 degrees. Do you see that? And then angle Z is going to be easy now to find because this is a triangle. This is a triangle. We can find angle Z there. Done. So angle Z is what? It's going to be 50 degrees because Z plus Y plus 40 must give us 180. Angle sum in a triangle. So Z is going to be 50 degrees. Done with that. Okay? You think you can do another activity? We're almost done. Don't get tired. Now we're going to do another activity again. Okay? And then you want to make sure that you understand how we apply these theorems. We've done what? We've done the proofs. So now how do we apply these theorems? Okay? Right. We have to try. Keep on trying. Okay, let's look at this one. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. We talked about this before. Do you remember when I was introducing the lesson? So this angle, which is the exterior angle, is equal to the opposite interior angle. You don't need to know how to prove this theorem. You have to know how to what? To apply it. And then this is the reason. Exterior angle of a cyclic quad. Okay. And then we can say also A1 is equals to C here. That's the reason here. Exterior angle of a cyclic quad. Okay. Right. Sorry for that. I was saying A1 is equal to C. This angle here is equal to this angle here because exterior angle of a cyclic quad. Then the converse of that. We're putting things on the other way around now. If the exterior angle of a cyclic quadrilateral, no, not cyclic quadrilateral. If the exterior angle of a quadrilateral, we can't say it's cyclic now. You see, there's no circle there. Right. If the exterior angle of a quadrilateral is equal to the interior opposite angle of the quadrilateral, then the quadrilateral is cyclic. You see that? Then we can say now this is cyclic after doing that. You see that? We start with this. If this angle is equal to this angle, then ABCD is cyclic. Okay? Right. That's the converse theorem. Right? And then the reason you write, you can say exterior angle equal interior opposite angle, or just say converse of exterior angle, or converse exterior angle of cyclic quad. Done. Okay? Maybe it will be easier to remember this. Just say converse. Okay? Right. Now, we need to apply that. If A1 is equal to C, I've shown you that. I'm just showing you that part then ABCD is a cyclic quad. Okay, I was just showing you that part. Now, let's try to apply what you've learned now. Okay, we need to find the value of X and the value of Y. If we're going to spend 2 minutes to find X and 2 minutes to find Y, that is 4 minutes. And then after those 4 minutes, we'll discuss and mark our work. Let's try grade 12s. Right, welcome back, grade 12s. Right, now let's look at the information. Given cyclic quadrilateral ABCD, and then we have angle C there, 78 degrees, angle CDE there, 105 degrees. What do you see? We're just given that it's a cyclic quad. Then you should be thinking about the exterior angle of a cyclic quad, okay, and then opposite angle of a cyclic quad. Remember those things. Now let's look at this angle here and this angle here. You see that? Okay, we can be talking about this angle here, there, and there. What can you say about those two angles? And then let's look at this one and this one. What can you say about those two angles? Are they equal? Okay, let me use another color to show you that these ones are different. Let's say this one and this one. Okay, right, I'm just like working on a piece of paper here. Okay, right, trying to fill in the information on my diagram. Okay, right now, so it means x is equal to 78 degrees, y, x is equal to 78 degrees, y is equal to 78 degrees, exterior angle of a cyclic quad. Okay, this and this. And then what about y? Y is going to be equals to 105 degrees, exterior angle of a cyclic quad. You see that? Done. Did you get those answers? I gave you enough time to answer those, isn't it? Right, okay. We're almost doing the last one, the last activity now. We've done a lot of work today, grade 12s, okay? Let's try the last one. Okay, let's see. Now, A, B, C, D are points on a circle. C, F, and B, E are drawn. Okay? Sometimes things just make us get confused and all these things. Just pick the key information there. Right. ABE equals 60 degrees. And angle FCD is 80 degrees. And angle ADB is 30 degrees. All that information is on the diagram. Right. Now we want to find the value of X and Y. Okay. Right. I'm going to give you 2 minutes to fill in as much information as possible on the diagram, and then after 2 minutes we just do this together and then we summarize our lesson. Let's try that for 2 minutes. Right, did you manage to try grade 12s? I really hope so. Did you get the angles? Did you get your X? Did you get your Y? I really hope so. Let's do it together. Right, now I can see I was also checking when you're busy working on it. I was also working on it. I have different things that I have here, a lot of different things, and then I'm just selecting what I think I will use to answer the questions. Right now, this angle here, exterior angle of a cyclic quad, is equal to the opposite interior angle of a cyclic quad. These two angles are equal, okay? Right, so these two angles are equal. Okay, any other angle? Let me try to use a different color. Right, and then this one also, exterior angle of a cyclic quad is equal to the opposite interior angle of a cyclic quad. These two angles are equal. That's what I saw. What else did I see? Let me see if I can have other things that are almost the same. Right, this angle here, this one, is equal to this angle. Why? They are subtended by the same chord AP. Do you see that? They are subtended by the same chord AP. Their angle is in the same segment. You see? Okay. And then I have another angle. Did I miss something? This one. This angle and this angle. Also they are equal. Do you see the chord DC or arc DC? It subtends these blue angles. So these blue angles are what? Are equal. Okay, what else? Did I miss something? Okay, right. Let's see if I have information that I can use here. So this whole angle, the red one, this one here, it means it is equal to 60 degrees because it's an exterior angle of what? Of a cyclic quad. Okay, is equal to the opposite interior angle. So we can say 30 plus x is equal to 60 degrees, isn't it? And then we can solve for x. Okay, right. And then once we get that, we can find our y. How can we find our y? Let's see what I did here. Right now, x, we say B1 is equal to D because exterior angle of a cyclic quad, you see, this angle here is equal to this angle here. Okay, because it's a cyclic quad. So 60 is equal to 30 plus x, therefore x is equal to 30 degrees. So this angle there is 30 degrees, okay? Right, and then we have what? We need to find y. We need to find y here. Right, y, what do we do? D2, where's D2? Is equals to A1. Right, this angle here is equal to this angle here. Did I miss that? I think so, because this is the same chord BC. They are subtended by the same chord BC. So they are angles in the same segment. I missed that, I think, when I was looking at the information. Okay, and then so A1 is equal to 30 degrees. So this one is 30 degrees, isn't it? A1 is 30 degrees there. Okay, and then now, what about this one? We say this is equivalent to 80. You see that? Exterior angle of a cyclic quad. So it means 30 plus y must give us 80, isn't it? Okay, and then there we can solve for y. So y is equal to 50 degrees. Okay, right. If you manage to find both of them, x and y, I think we've managed to do so. Right, I really hope you learned something, grade 12s. This is not enough for you to be able to get all the marks in Euclidean geometry. You have to continue working with the past examination questions and make sure that you're getting all the marks. This is a very, very easy topic and it's very, very interesting. Continue working at just work on a writer every day. Then you're going to be fine. Okay, right. I really hope that you learned something in today's lesson. Let's just summarize our lesson and then we end it. Right, we said what? Equal chords subtend equal angles at the circumference of the circle. Do you remember that? Angles, equal chords subtend equal angles at the circumference of the circle. Those corollaries, okay? And then said equal chords subtend equal angles at the center of the circle. So here the reason you say equal chords, equal angles, right? And then equal chords in equal circles subtend equal angles at the circumference of the circle. Equal angles, equal chords, equal, equal circles, equal chords, equal angles. Okay, remember that. Equal circles, equal chords, equal angles. And then equal chords in equal circles subtend equal angles at the center of the circle. Equal circles, equal chords, equal angles. Remember that. And then the opposite angles of a cyclic quad are supplementary. Remember that? Opposite angles of a cyclic quad. And then we said if the opposite angles of a cyclic quad I always say this is a big mistake. Right? If the opposite angles of a quadrilateral, Okay, not a cyclic quad. If the opposite angles of a quadrilateral are supplementary, then the quadrilateral is cyclic. Okay, all right, remember that. And then the exterior angle of a cyclic quad is equal to the interior opposite angle, okay, of that particular cyclic quad. And then if the exterior angle of a quadrilateral is equal to the interior opposite angle of a quadrilateral, then the quadrilateral is cyclic. That's the converse. Okay, right. We did a lot of things in today's lesson. Thank you very much, grade 12s. Let's meet in our next lesson. Remember to continue doing your best. Let's meet in the next lesson. Goodbye.